in each of these questions, 2 conclusions have been given followed by 5 sets of possible statements. You have to take the given conclusions to be true even if they seem to be at variance with the commonly known facts, and then decide for the given conclusions logically follows from which of the given statements. Okay, so same as syllogism, it is just reversed. Conclusions have been given. We have to find out for these 2 conclusions which of the set of statements is correct, or for which set of these statements will these 2 conclusions follow. You getting it? Now what are the conclusions? No toxics are injection and some injections are glucose. There are 2 conclusions. First one is no toxics are injection. Second one is some injections are glucose. Now there is nothing to be done on the conclusions here. All that we have to do is on the statements only. So for the given set of statements, draw the basic diagrams, right? So all glucose are medicine. All glucose are medicine. Some medicine are toxic. Some medicine are toxic. Some toxics are injection. Some toxics are injection. All injections are insulin. All injections are insulin, right? I'm not explaining the basic diagram because you know how to do it, right? Now if you look at this basic diagram and now look at the conclusions in the question. No toxics are injection. Is it true? No toxics are injection? No. Clearly, injections and toxics are overlapping, right? In fact, you need not even draw the diagram. Directly when you look at this statement here, the statement said some toxics are injection, but the conclusion says no toxics are injection. So will this be correct? No. First option will be wrong. Because in the statement when he says some A's are B's, how can the conclusion be no A's are B's? For some A's are B's, the definite conclusion is some B's are A's. You cannot say no A's are B's. So first one is wrong. First statement is wrong. Need not even draw the diagram that way, right? Similarly, see in the second one if you have got something. I mean, first before drawing the diagram, we know the conclusions are no toxics are injection, some injections are glucose. So it will be hard to verify using some injections are glucose, but no toxics are injection. No, there is nothing directly given between toxics and injection. So let us draw the diagram for the second one. What happens? Some toxics are insulin. Some toxics are insulin. Some insulin are medicine. Some insulin are medicine. All medicines are injections. All medicines are injections. And some medicines are glucose. Some medicines are glucose, let's say. Okay. Now, no toxics are injection. Is it true? Well, if you look at the basic diagram, yes, no toxics are injections is true. But will it always be true? Some injections are glucose is true. Look at the second conclusion. Some injections are glucose is true. Yes, injections in glucose is true. So second one is satisfied, but the first one, see, no toxics are injections satisfies the basic diagram, but will it always satisfy? No, it will not satisfy always. How can we say that? Because, I mean, this is only the basic one. I can draw the possible diagram in such a way that, you know, when he said all medicines are injections, instead of drawing injections like this, let us draw injections like this. All medicines are injections. I'll draw injections like this. Let's say IJ dash. This is the initial way of drawing injections, but now I'm drawing it like this. The statement said all medicines are injections. So all the medicines are injections. But the moment you draw this diagram, what do you find? No toxics are injections become false because all the toxics are coming inside injections. So the second one also is wrong. That's it, the same thing. See, because I'm explaining it to you, it is taking so much of time. When you do it yourself, you'll do it really fast, really quick, right? Similarly, check the third one, fourth one, fifth one, you'll get the answer. See again, in the third one, see option C, right? Try to verify. All toxic are insulin. All toxic are insulin. Some insulin are medicine. Some insulin are medicine. Some medicines are injections. Some medicine are injection, right? In fact, I'll do one thing. I'll try to draw a diagram in such a way that the conclusion is false, so that it is easy to eliminate. You getting it? Instead of drawing the basic diagram, maybe you try to draw the diagram in a way that you can prove that the conclusions are getting false. Like for example, all toxics are insulin. Some insulin are medicine. Next statement says some medicines are injections. Now can you draw some medicines are injections like this? Some medicines are injections? Yes, some medicines are injections. But in this process, you find that toxics and injections are also overlapping. But the conclusion said no toxics are injection, which means C is also wrong. This also is wrong. You're able to follow. In the first 2 cases, we have drawn basic diagram. This was a basic diagram. This was a basic diagram. But smartly, what you can do is, instead of drawing the basic diagram and then checking the possible diagrams, if you can visualize which diagram would make it false, try to directly draw that type of diagram. Here, this is a possible diagram. It tells me that the first conclusion is false. Look at the D1. So this is for A, this is for B, and this is for C. I don't have enough space for D. Let me draw for conclusion, option D here. Option D, right? All glucose are injections. All glucose are injections. All medicines are glucose. All medicines are glucose. Okay, so space crunch here. Let me draw it a little smaller in size so that we can accommodate everything. All glucose are injections. All okay, all glucose are okay, sorry, I think I read the wrong this one. All glucose are injections. All glucose are injections. Some injections are medicine. Some injections are medicine. All injections are insulin. All the injections are insulin, right? Some insulin are toxic. Some insulin are toxic. So again, I'll try to draw a diagram in such a way that one of the conclusion goes wrong if it is really possible. And yes, some insulin are toxic. Can I draw some insulin are toxic in this way? Some insulin are toxic. See, some insulin are toxic. But in this process, we also find that some injections are also becoming toxic. See, some insulin are toxic means this shaded region, fully shaded region. But some injections are toxic, this completely shaded region. So the point is, the conclusion says no toxics are injection. But here we find that some toxics are injections. So which means D also is wrong. So when A, B, C, D are wrong, E has to be correct. E has to be correct. Are you able to follow? So that's about it. But then in this particular case, there is a smarter way of solving the question. Like I said, you need not even draw a single diagram to get the answer for this one. But before I explain that, let me draw the diagram for E also, option E also, so that we can verify the whole thing. Okay. So let me draw it for option E. I'll draw it here. All glucose are injections. All glucose are injections. Some injections are medicine. Some injections are medicine. All injections are insulin. All the injections are insulin. And no insulin is toxic. No insulin is toxic. So insulin and toxic should not touch each other. Now look at the conclusion. The first one, no toxics are injection. No toxics are injection. Is it true or false? True. See, toxic cannot touch insulin. When toxic cannot touch insulin, how will it touch something which is inside insulin? So no toxic is injection is correct. So first one is correct according to the option E. Some injections are glucose. Some injections are glucose is also correct. Because all glucose are injections. When all glucose are injections, some injections are glucose. You're able to follow. All glucose are injections. What's the definite conclusion? Some injections are glucose. Some injections are glucose. Second one also is correct. So option E is the correct answer. Option E is the correct answer. Now, how do we do it in a smart way? This is one way of doing it, traditional way of doing it. But in some cases, we can solve the question using a smart way. How? Let us first understand, the negative and positive nature of the statements. See, when you say all A's are B's and some A's are B's, these are like positive statements. Yes or no? These are positive ones. But no A is B, some A's are not B's. These are negative in nature. Yes or no? These conclusions, these types of statements are negative in nature. Now, the advantage we have in this particular question is that the given conclusion is negative. No toxics are injection. No toxic are injection. Now, one point that you need to understand is for a negative type of conclusion, which is negative in nature, no toxics are injections, or some injections are not toxics, or some toxics are not injection, any of these two types. So when a conclusion is negative type, definitely at least one of the statements has to be negative. Otherwise, it is impossible to get a negative conclusion. Or in the reverse way, I can say when all the statements are positive, when all the given statements are positive, positive meaning all A's are B's, some A's are B's types of statements are there, then we can never get a negative conclusion type. Are you able to follow? This is like simple logic that you need to understand. When a conclusion is negative, definitely one of the statements has to be negative. Or when all the statements are positive, the conclusions can never be negative. Going by that, you see that the conclusion here is negative. No toxics are injection. So clearly, at least one statement has to be negative. Look at option A. All glucose are medicine, positive. Some medicines are toxic, positive. Some toxics are injection, positive. All injection are insulin, positive. When all four are positive statements, the conclusion can never be negative. You understand? We can draw a possible diagram where all these negative conclusions can be ruled out. So that is the reason conclusion cannot be negative when there are all positive statements. So option A is ruled out. Similarly, option B. positive, 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 cannot be the answer. Option C, positive, 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 cannot be the answer. Option D, positive, 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 cannot be the answer. Option E, positive, 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 and negative. You see, and this is what has made the first conclusion to be true. No toxic cell injection. So option E is the answer. At least some amounts are costs, all amounts being prices is a possibility. Now you very well know that the word at least here, or the words at least, make no difference, right? At least some or some are same, means the same, right? Makes no difference. So the conclusions are some amounts are costs, all amounts being prices is a possibility. So one is a definite conclusion type, the other is a possibility type. Okay, so you have to check it accordingly. Fine. Now verify. Now there's nothing like negative here, right? So it would be difficult to do it directly. Let us draw the diagrams there. Only 3 statements, so it should be easy. Some costs are prices, some costs are prices, some prices are amounts, all amounts are expenses, all amounts are expenses. So when you look at the first one, some amounts are costs, no. In the basic diagram itself, you find that the first conclusion does not satisfy. Some amounts are costs does not satisfy. So the first one is wrong, right? Second one, some prices. So this was A. I'm drawing B now, right? Option B. Some prices are costs, some prices are costs. Some costs are amounts, some costs are amounts, all amounts are expenses, all amounts are expenses, all amounts are expenses. Now look at the conclusions. First one, some amounts are costs, yes, some amounts are costs, satisfy. And you know that it will always satisfy. Even when you draw a possible diagram, it will always satisfy. And again, moreover, I think drawing the diagram is not needed, because some amounts are costs, some costs are amounts. You see, for some costs or amounts, the definite conclusion is some amounts are costs. So without drawing the diagram, you can say that yes, at least the first conclusion is satisfied in the option B. Yes or no? For some A's are B's, the definite conclusion is some B's are A's. So when the statement is some costs are amounts, the definite conclusion will be some amounts are costs. So no need to draw the diagram to verify that. But anyway, let us go for the second conclusion now. All amounts being priced is a possibility? Possible. Again, this point here is, if you go by logic, here also you need not draw the diagram, because he is talking about a possibility which is a positive type. All A's are B's, all amounts being priced is a possibility. Remember, again, I am talking about same positive negative nature of the statements. For a positive type of possibility, you can directly say that it is always true when the given statements are all positive in nature. All the statements are positive here. Some prices are costs, some costs are amounts, all amounts are expenses. So when all the statements are positive, positive meaning what? All A's are B's, some A's are B's types of statements, then any possibility which is positive type is possible. We can always do that. Are you able to follow? Like here in this case, this is the basic diagram for B. Let me draw a possible diagram for B now. What do we want? We want all amounts to be prices. Here all the amounts are not prices. But how can we do that? Let me draw a possible diagram. How can you draw a positive diagram? Since all the statements are positive, I can only draw one circle and say everything is the same circle. Prices, costs, amounts, expenses. How can I prove it? Some prices are costs. Yes, some prices are costs. Some costs are amounts. Yes, some costs are amounts. All amounts are expenses. Yes, all amounts are expenses. And now go back to the conclusion here. All amounts being prices is possible. Yes, all the amounts are prices. So you can conclude that option B is the answer. The second option is the correct answer. Here again, if you have understood the logic that I've talked about, you need not draw the diagrams, right? For the first conclusion, there is a direct statement given to us. Some costs are amounts. So definitely some amounts are costs. So no need to draw the diagram for that. And the second conclusion is a possibility type, that to a positive possibility type. And like I've mentioned, if all the statements are positive type, then any positive possibility is correct. So all the statements are positive type. Some A's are B's, some A's are B's, all A's are B's. The possibility given here is all A's are B's types. So yes, it will be possible, because I can always draw one diagram and prove that it is correct. So option B is the correct answer, and we will not worry about option C, D and E, because anyway we have found one option which satisfies the given conclusions. Okay. Some homes are floors is a possibility. Some ships are not cities. Some homes are floors is a possibility, and some ships are not cities. Right? Some ships are not cities. So I think the easiest way to do is just quickly draw Venn diagrams for the given options and see which option satisfies both the conclusions. So if I look at the first set of options here, first option which has got statements, all floors are antenna, right? All floors are antenna, all floors are antenna, then all antenna are ships, all antenna are ships, no antenna is a city, No antenna is a city, and no hospital is a ship, and no hospital is a ship. Right? No hospital is a ship. You understand the basic diagram, right? All floors are antenna, all antenna are ships. No antenna is city. So antenna and city will not overlap with each other, and no hospital is ship. Hospitals and ships will also not overlap with each other. So 2 cross marks indicate these two circles will not touch each other. Single cross mark indicates these two circles wouldn't touch each other. Okay. Now if you observe, just check whether the two conclusions given here follow the given diagram or not. So some homes are floors is a possibility. Some homes are floors is a possibility. Is it possible? Some homes are floors? It's not possible here, because you see, homes cannot touch ships. If homes cannot touch ships, how will it touch anything that is inside ships? Floors and antennas are always going to remain inside ships, right? And homes, it cannot touch ships, hence it cannot touch floors. So saying that some floors are homes, some homes are floors is a possibility would be wrong. It is not possible. So first one fails. We don't even have to look at the second conclusion now, right? From the first conclusion itself, we know that statement 1 is wrong. Look at statement 2, option 2, right? What is option 2? Some floors are antenna. Some floors are antenna. So some floors are antenna. All antenna are ship. All antenna are ship. Then some antenna are city. All antenna are ships. Some floors are antenna. All antenna are ship. Then some antenna are city. Let's say some antenna are city. And no hospital is a ship. No hospital is a ship. So hospital and ship would not touch each other. Hospital and ship will not touch each other, right? So what happens? Look at conclusion number 1. Some homes are floors is a possibility. First conclusion, some homes are floors is a possibility. Is it possible some homes are floors? Well, yes, if you see, it is possible, because homes cannot touch ships. Homes should not touch ships, anything that comes inside ships. But homes can go and touch, the cities and floors here, right? Like for example, homes can also be drawn in this way. Other possible way of drawing homes. One possible way of drawing homes here in this diagram is this one, because the statement said that no hospital is a ship. Even in this case, no hospital is a ship. We have not violated any of the conditions, right? Hospitals and ships are not touching each other. However, you find that some homes become floor. So some homes being floors is possible when you look at statement 2. Now check the second conclusion. Some ships are not cities. Some ships are not cities. Some ships are not cities. Well, some ships are not cities has been satisfied in the basic diagram again. Some ships are not cities is satisfied here. You can choose all these ships which are outside, right? These ships are not cities, right? Outside ships are not cities. Outside ships are not cities. But will it always satisfy is the question. Will it always satisfy? Will this always satisfy? Some ships are not cities. See, when will some ships not cities become false? When all the ships are cities. And can all the ships be inside cities? Yes, it is possible. How is that possible? Look at the third statement here, right? Some antenna are city. Some antenna are city we have drawn in this way. Some antenna or city has been drawn in this way. But can we also draw the cities in this format? See, forget about this purple C. Look at the blue C. It is a possible diagram, right? Whatever I have drawn in blue here indicates the possible diagram. So if I draw ships in the cities in this way, what was the statement? Some antenna are city. Some antenna are city. Yes, even now some antenna are city. But the fact is, when some antennas or cities are drawn in this way, all the ships are inside cities. All the ships you see have come inside cities. So can we say some ships are not cities? No, some ships are not cities cannot be concluded from this one. Hence, statement 2 also false, is also false, right? Option 2 also fails. Look at option 3 now, right? Option 3. What does it say? All floors are antenna. All floors are antenna. All antenna are ship. All antenna are ship. Some antenna are city. Some antenna are city. And sorry, I think I was reading the wrong set of statements. I'm sorry about that. Yeah. Okay. All floors are antenna. We have drawn this. All antenna are ship. We have drawn this. And no antenna is a city. No antenna is a city. How do you draw? No antenna is a city. No antenna is a city. So antenna is here. City is here. So no antenna is a city. Antennas and cities will not touch each other, right? Antennas and cities will not touch each other. And finally, all homes are ships. All the homes are ships. So all the homes are ships means what? All the homes should be inside ships, right? We are trying to do minimum overlapping. Minimum overlapping. So all the homes are ships. Okay, looks like there's some confusion here. Sorry, I was not looking at the chat. But in the first two Now this was posted by Ram and I think we took it as it is without doing a proper verification. But the point is, in the conclusions given, we are talking about homes. Look at this. Something is wrong here. I just looked at the chat. We're talking about homes, but homes is nowhere given in the statements, right? In fact, we have hospitals in place of homes. But homes is here. Yeah, so does that mean that I could have eliminated, statement 1 and statement 2 directly? Because homes is not even mentioned there. I mean, since I was taking only H for homes, I thought H is hospital and continue doing it. But yeah, if you actually see, strictly speaking, the word homes is not even used in the statements. So how will we verify? Second set of statements also, the word homes is not used. In the third, fourth and fifth one, homes is used. Anyway, we have verified 1 and 2. I think this is the error, right? Hospital should be homes, right? No home is a ship, no home is a ship, etc. But anyway, let's look at third statement now, right? Third statement. So third statement says all floors are antenna, then all antenna are ship, no antenna is a city, antenna and city do not touch each other, and all homes are ships. All the homes are ships, all the homes are inside ships, right? Remember, we are drawing a basic diagram, so you have to always keep in mind minimum overlapping. Like for example, I can also draw a bigger circle for homes, but why to unnecessarily make homes overlap with antennas or floors here? Try to keep it minimum, right? That's the whole idea. Basic diagram means minimum overlapping. Now check the conclusions quickly. Some homes are floors is a possibility. Some homes are floors is a possibility. Yes, it is possible. See, in the current basic diagram, it is not possible. Homes and floors are not touching each other. But like I said, can we draw bigger homes? Yes, we can draw bigger homes. Instead of drawing, like, what was the statement? All homes are ships. All homes are ships can also be drawn in this way. Possibility, let's say. If you draw all homes are ships in this way, then some homes are floors will become possible. The shaded region, you see the shaded region here. Some homes are floors is a possibility. Yes, it is possible. Then the second thing that we need to verify, some ships are not cities. Some ships are not cities. Is it true? Yes, definitely true. How can we say it is definitely true? See, we know that all the antennas are inside ships. All the antennas here are inside ships. And no antenna can be a city. No antenna can be a city. So definitely there will be some ships. Which ships? All the ships which are antennas, right? See, basically all the antennas are ships. So antennas can be replaced with ships. Antennas, all antennas. What did the statement say? All antenna are ships. So wherever we have antenna, we can actually replace with ship. I gave this technique earlier also, right? When we say all A's are B's, wherever we have A, it can be replaced with B. So all antennas are ships means antenna is equal to ship. Ship is not equal to antenna, but antenna is equal to ship. So wherever we have antenna, we can write ship in that place. So instead of saying no antenna is city, I can say no ship is city. No ship is city. And if I can say no ship is city, then I can say some ships are not cities. Because the definite conclusion for no ship is city is some ships are not cities. Some ships are not cities. We can always prove that these ships are not cities. Right? These ships which are inside antennas are not cities, because antennas and cities cannot overlap. So statement 3 has followed both the given conclusions. Right? Statement 3 has followed both the given conclusions. So I think statement 3 can be taken as a correct answer. Alright. See, it may look lengthy because I am giving a detailed explanation, but when you do it yourself, I am sure you don't have to think about it so much, right? It's all about drawing the basic diagram, right? You should know how to draw basic and possible diagrams, and where to use possible diagram, where not to use possible diagram. All these things have been discussed in our video, right? Syllogism video. So I urge all of you to just go through that and watch it once again. Okay. Now, no need to verify fourth and fifth statement because we already got option 3 as the answer, but I can see from the chat that statement 5 also follows both the conclusions. So let me check statement 5 once. Somebody has mentioned in the among the students that statement 5 also follows. Well, ideally it should not happen, but let's just check. Fifth one, I'm not drawing fourth one, assuming that it doesn't follow. Look at fifth one. Some floors are antenna. Some floors are antenna. All antenna are ship. All antenna are ship. Some floors are antenna. All antenna are ship. No antenna is city. No antenna is city. So antenna and city do not touch each other. No antenna and city. And some homes are cities. And some homes are cities. Some homes are cities. So this is the basic diagram, right? Basic diagram for option 5. All floors are antenna. Some floors are antenna. All antenna are ship. No antenna is a city. And some homes are cities. Some homes are cities. Now go back to the conclusions. First conclusion, some homes are floors is a possibility. Some homes are floors is a possibility. Yes, it is possible. See, in the basic diagram, it is not possible. But I can always draw homes in this fashion, right? Like instead of drawing H like this, can you not take H in this fashion? Because the statement said some homes are cities. Some homes are cities. So here also you can find that this overlapping region, right? The shaded region shows that some homes are cities, right? Some homes are cities. And at the same time, you find that homes and floors are also overlapping. If you try to do this possible diagram, you find that homes and floors are overlapping. So can we say some homes are floors is a possibility? Yes. Some homes are floors is a possibility. So the first one follows. First one follows the fifth set of statements. What is the second conclusion? Some ships are not cities. Some ships are not cities. Is that true? Well, yes. Like what we have seen in the previous case, right? In conclusion 3, I mean in statements 3, same is applicable for statement 5 as well. You're getting it? It is the same thing. If you see, I'll highlight two portions here. Try to look at this. All antenna, sorry. Right, look at this. All antenna are ship, no antenna is city. All homes are ships. Here also, all antenna are ship, no antenna is city. Some homes are cities. Some homes are cities. Well, so same statements. All antennas are ship, no antenna is city. All antenna are ship, no antenna is city. And because the set of statements is same, I think this conclusion will be followed in fifth case also, right? Some ships are not cities. Some ships are not cities. Which ships will not be cities? Some ships are not cities. So these ships which are antennas will not be cities, because definitely there are antennas inside ships and antennas cannot be cities. So we can say some ships are not cities. Some ships are not cities. So fifth one also satisfies, interestingly. Fourth one I have not verified. I hope it doesn't follow. So now what's the question? How do we decide which is correct? Is it 3 or 4? Is it 3 or 4? Or have we committed a mistake somewhere? Look at 3. All floors are antenna. All antenna are ship. No antenna is city. All homes are ships. All homes are ships. So when I look at the conclusion, some homes are floors is a possibility. Some homes are floors is a possibility. What is wrong in that? Some homes are floors, possibility. Some ships are not cities. Some ships are not cities is also possible. So I think 3 and 5 both satisfy, right? 3 and 5 both satisfy. So Ram, you just have to look at the look at the source of your question here, right? Because I think the answer is option 3 and option 5. The final answer to this question is option 3 and option 5.